Position, which is represented as s of t, is where the particle is at a specific moment in time. Velocity, which is the derivative of position, is the change in the particle's position as time passes. Acceleration, which is the derivative of velocity and the double derivative of position, is the change in the particle's velocity as time changes. Speed is the absolute value of velocity, which means it is always positive. Initially is when the time is equal to 0. At the origin means the position is equal to 0, and at rest means the velocity is equal to 0. Please read the following FRQ, which is calculator permitted. You should be done now. The first question asks us to find the acceleration of the particle at time t equals 4. To find the acceleration, we must first find the derivative of the velocity. That equals 2t minus 3 over t squared minus 3t plus 3. Now to find t equals 4, we plug in 4 to the derivative of the velocity. After we do this, we get our answer after we saw, which is 5/7. Question 3b asks us to find all the times t in the open interval 0 through 5 at which the particle changes directions. Also, during which time through the interval 0 through 5 does the particle travel to the left. We know that the particle changes directions when v of t equals 0. If you look at the graph, you'll see that v of 1 and v of 2 equals 0. Therefore, the particle changes directions at t equals 1 and t equals 2. Now, the particle travels left when the velocity is negative. So, the velocity is negative on interval 1 to 2. Question 3c asks us to find the position of the particle at time t equals 2. In the question, we are given that the particle is at position x equals 8 at time t equals 0. So now we solve for x of 2. After adding 8 plus this, we get 8.369. Question 3d asks us to find the average speed of the particle over interval 0 to 2. To find the average speed, we need the total distance over the total time. To find the total distance, we first need to find the integral from 0 to 1 of v equals t, v of t, plus the integral of 1 to 2 of v of t divided by 2. The first integral gives us 0.5548 minus 0.1862 over 2, which equals 0.371. Here are two examples of particle motion, one example done graphically and the other example done analytically.